Okay. So I have already sent a question on group, which we are going to go through. It's wordy because it contains all the parameters we need. The mean, the variance, standard deviation is part of variance, then also the decile, median, quartile, percentiles, then conversion also from capital Fx to small fx. All those are there. That is why it is a little wordy. So an item cannot be that long. I've made it long so that it can contain all the parameters we shall need. All the parameters we shall need. But an item cannot be as detailed as that. It has to be a little brief. It has to be a little brief. So shall go through it step by step, and I encourage you to be inquisitive. Ask where need be inquisitive so that you are not left behind. That you're not left behind. So like I told you in the first meeting, that your questions will always be scenario. That is why this time around I'm emphasizing on scenario approach. So all the questions we shall be using this holiday will be scenario based. And like I've told you, I'm compiling a certain item bank. So when the holiday program is over, I encourage you to get yourself a copy of that item bank. So this item says, in Kampala City, Kampala KCCA is studying the time in hours it takes a boda rider to complete a delivery within the city during off-peak hours. Because traffic conditions vary smoothly with distance, road conditions, and rider decisions, the delivery time is modeled as a continuous random variable. Like I've told you yesterday, that continuous, the previous lesson, is either a straight line or a curve. That's what shows that it's continuous. Because discrete, it is just whole number, something countable, whole number. But continuous, it contains even decimals. So it's modeled as a continuous random variable. If it was countable, then, but time has decimals. So time is as a continuous random variable. Temperature, it has decimals. So it is a continuous random variable. Like that. So anything which is continuous, anything which has, what involves decimals, and you can't count it as a whole, it becomes a continuous random variable. Okay. So this one tells us that we're now dealing with continuous. So if I see you tabulating in your solution, then problems have begun. It means that you are treating it as discrete, yet it must be continuous. So here what I expect to see is approach for continuous. If it is capital Fx, simply substitute. Small fx, integrate. Like that. That's what I want you to remember. So it says, from collected data across different divisions of cases of Kampala, that is the divisions which make up Kampala, KCM models the cumulative distribution function, capital Fx, of the delivery time, capital X, as follows. So the recommendation from NCDC requires that we don't give you the function as direct. It is you to read the scenario and come up with your own equation. So the previous scenarios you've been doing, I think you have been saying, for example, differentiation, they give you an expression, maybe this plus 1 over this, then here you differentiate. Okay. But the scenarios they recommend, it is you to come up with a function, then you differentiate. So it will be a little different from the ones of all level you were used to. But don't worry, you'll get there. Don't worry, you'll get there. So when here they break down, then it is you to come up. Even here I helped you by writing the expression, but it is recommended that they give you this expression in words. Then you come up with the actual expression mathematically. So there will be word problems and you come up with a mathematical expression, then you solve it to get the answer. So, but don't worry, you'll get there. So for negative values means x, anything less than 0 is a negative. So that means that if we're doing this, it means that when you put 0 here, we should put x less than 0. Okay? Then for delivery time between 0 and 1, I think I told you last time we agreed that these ones don't, because if it was discrete, between 0 and 1, it must be this. Okay, but because this is continuous, any is okay. Someone can do this. You are still correct. Reason, it is continuous. So this one shouldn't disturb you. It shouldn't disturb you. It is continuous. That's why we don't mind, we don't overmind whether you put O equal to or you don't. So it means 0, then kx squared. This is for x less than 0. This one is for 0, 1. Then you also proceed. There's another bullet. Then for this interval, we have this expression. So meaning that if you have to complete it, you say 0, then kx squared, then also k in brackets 2x minus 1. The intervals should be correct. 1, then here this was 0, then here it was x. Okay, then we end with, okay, there's also another one, this one. There is also k in brackets 8x minus x squared minus 10. Then that means for which interval from 3 to 4. Then there is 1, which is anything beyond 4, like that. So we expect you to read the scenario and come up with this for on your own. So previously, some scenarios you will see they give you this exact directly, but that's not all the recommended one. That is not the recommended one, but we shall get there. So here, fx represents the probability that a border delivery in Kampala is completed at most. I think you remember in this introduction part, we say that capital Fx is the same as probability of x less or equal to x. That is what this statement means. Capital X is the same as at most. At most means you don't exceed that. So these two are equal. These two are equal. That's what the statement is trying to mean. Then K is a constant. So that one must be clearly specified that K is a constant. Because if it's not a constant, then problems have begun. Problems have begun. So task part A, determine the value of the model constant K and hence sketch the graph of capital Fx. I think let's begin with that. So it all begins by combining all the expressions and write it in the format which is easy to deal with. So that's what I'm trying to mean. Combine all in a format which is easy to deal with. Then you can start. Remember, okay, let me ask, because we did it yesterday. We want to find the value of x. How can we get the value of x? Anyone to give us an approach of how to get x? Sorry, not x, the constant k. How can we get k? Anyone to answer? Yes, anyone? Let me see. Kaitesi, do you have an idea based on based on last time's lesson? Precious, do you have an idea on how to get the value of k? Chirabo, Janet, Yes, Chirao, you have an idea?
Teacher, I don't.
Mm. Any fortunate? We are given capital Fx and we want to get a constant. How can we get the constant? Vanessa?
Teacher, I think we simply substitute.
Yeah, that's what I want to hear. Simply substitute. Substitute what? What are we going to write?
Uh, I'll write F into brackets 4.
Mm-hmm.
Then I put K
Mm-hmm.
into brackets 8 times 4
Mm-hmm.
minus 4 squared
Mm-hmm.
minus 10.
Okay.
Yes.
Just that alone.
Then you calculate.
How? Because they will not get k, the value of k, isn't it? You should be equated to something to make it an equation.
Sorry, you is equal to 1.
Why did you say 1?
Um, because the whole probability leads to 1. I'm not sure.
Okay, good try. Good try. So that is the idea. But why we say 1 is because of it's a continuous. Continuous means where one stops is where the other starts from. So this interval stops at x equal to 4. This one starts from x equal to 4. Meaning that when you put this 4 here and you put this 4 here, you must get the same value of y. By y, I mean capital Fx. So basically, we equate to 1 because this and this, they have the same value of y. So when this is put here and this is put here, we should get the same value. That is why we equate to 1. And like I said yesterday, even this is correct because you see this 1 and 1, that when you put 1 here and 1 here, you should get the same x value. But the problem with that is that the k will cancel away. Let's try. When I put f1, I'm going to get k times 1 squared, and here I'll get k times 2 times 1 minus 1. So I'll end up with k equal to k. So it doesn't make sense because k will cancel at the end of the day. That is why we don't use this one. But when we use, also we can't use this 3. When you use 3, still k will cancel. But when you use this 4, k will remain. That is why we chose 4. That's why we chose 4. Okay. So we shall come and say that F4 is that. Then now we can use a calculator to get the value of K. And after getting the value of K, it is advisable that you come and immediately substitute for K. After getting the value of K, immediately substitute for K. Just as we did for discrete, I think you remember, we could tabulate and we had column of X, then column of X equal to probability, and this value had K, isn't it? But after getting the value of K, we immediately came here and rewrote our probability of X equal to X, whereby we substitute for K. That was for discrete. The same concept works here. After calculate, here they had k, but after getting the value of k, immediately rewrite this expression with k substituted. Rewrite the expression with k substituted. They don't need to tell you. They don't need to tell you to write. You have to write it for easy follow-up of the question. Okay, so now that you have got capital Fx, let me see what they asked. They say determine that is part C. Determine the value of the constant and hence sketch Fx. Hence sketch. So sketching, you should know what is a line and what is a curve. A line means that the x has power 1 strictly. So a line should be in this form, y equal to mx plus c. Now, when you look at these functions, this one has a power, so it becomes a curve. This one has a power, so it becomes a curve. This one is a straight line, so you should use a ruler. So when you're drawing, you should be mindful, know when to use a ruler and when to use freehand. A ruler is used when the expression is a straight line. So this is linear. If I see using freehand in that region, then it is never okay. Okay. Then next, remember standard curves or standard quadratic curves. When it is like this, it means that the coefficient of k of x is positive. When it is like this, it means the coefficient of x is negative. If you look at this one, it takes on this shape. If you look at this one, it takes on this shape. There you have to be mindful. So here we don't need to go through the details of paper one, where we say differentiate equal to 0 to get the turning point, all those things, the nature of the turning points. That is paper one. But here we need to know the standard shape. We need to have knowledge of the standard shape. What do we need? What we need are the corresponding y values for these extremes, these ones. So in short, when x is 0, what is fx? When x is 1, what is fx? When x is 2, is 3, what is fx? When x is 4, what is fx? So what we need are the corresponding values of y for these extremes, for those extremes. So let's try to get them. F0 means x is 0, we get 0. F1 means x is 1, so when I put this one here, I'll get 1 over 6. Like I've said, even if you use this expression, you still get the same answer. Let's try. 2 times 1 minus 1, it gives you 1. 1 times 1 over 6, it gives you the same 1 over 6. Okay? Then F3, it is you to choose what you want. I can use this expression. I can also use this expression. I'll get the same answer. Let's try 1 over 6. If I use this in brackets, 2 times 3 minus 1. 2 times 3 is 6 minus 1 is 5 to give you 5 over 6, which is here. Okay. What if I wanted to use this expression? What would I do? I would get 1 over 6 in brackets 8 times 3, okay, minus 3 squared minus 10. 8 times 3 is 24 minus 6 minus 10. So in short, 24 minus 16, it gives you what? Okay, let's begin by 24 minus 10 is 14. 14 minus 6, it gives you 8, I think. 8 over 6. When I reduce, let me first use a calculator.
Teacher,
Yeah, it is 9. Yes?
3 squared is 9.
Yeah, it is 9. I think that is better. Let me first try. 24 minus 9 minus 10 gives you 5. Yeah, so you're good to go. So it is still correct, 5 over 6. So in short, once these are the same, the corresponding values should also be the same. That's what they mean by continuous. That's what they mean by continuous. Same applies to 4. I can just use this. It is okay. Or I say, let me put the 4 here. It is still okay. 1 over 6 in brackets 8 times 4 minus 4 squared minus 10. 1 over 6 in brackets 8 times 4 is it 32? 8 times 4, yeah, 32 minus 16 minus 10. That is now 32 minus 26. 32 minus 26, it gives 6. So 1 over 6 times 6, it still gives you 1. So those are the points we want. The extreme points are the ones we get. Then we can use the knowledge of standard curves to know how the curve bends. How the curve bends. Okay, now let's try to draw a sketch. 0, 0. When x is f0 is 0, so there's a point here. Then 1. When this is 1, here we shall put 1 over 6. Then it is a curve. It is a curve. So it should bend in this form, like that, because it is a curve for a minimum point. It is a curve like this. So we take this shape. For this one, it is a straight line. So I'm going to come and say f3 is 5 over 6. So when I put here 3, I should go this side and get maybe 5 over 6. Now from here to here, you must use a ruler. You must use a ruler. It is a straight line. Okay. Then proceed. When I put 4, it goes to 1. So I'll come and look for 1 here, like that. Then I'll know that the shape is for a minimum like this. So I cut off, meaning that I should draw something like that. Okay. Then beyond 4, it is fully 1. So here from this point, I put a horizontal line, but I don't know where it stops, so I put an arrow. Then also here, x less than 0, I put an arrow this side. Then I start labeling. Here I'll say fx is equal to 0. Here I'll label this. Here I'll label this. Here I'll label this. Here I'll label this, like that. So basically that is how they sketch continuous random variables. You either use a line or a curve, depending on the expression given. So the full one is in that form. Everything must be labeled. But like I told you, I still forgot this. It is vital. X equal to 0. Okay, so that is part A, Roman 1 and Roman 2. If there's a question you can ask. Before we proceed to the next.
Excuse me, teacher.
Okay. Mhm.
Teacher, could you please pardon me? I know that it's a
One.
maximum or a minimum.
To know whether it's maximum or minimum. Positive coefficient
Yeah.
of x squared. If a quadratic expression has a positive coefficient, for example, if they say sketch the curve if they say sketch the curve, maybe 3x squared plus 3x plus 4. You don't need to go to first get the natural turning point to know whether it will be maximum or minimum. What you need to do, look at this coefficient of x squared. Because it is positive, it means minimum turning point. Okay, what if it was like this? 3x minus 4x squared plus 4. Look at this coefficient. It is negative, meaning that it has a maximum turning point, like that. So in math 1, you have to go through the details. You differentiate, equal to 0, then get the nature of turning point by either second derivative test. But in probability, we don't need those details. In probability, we don't need those details. What we need is how the curve curves. I don't know if that's correct English. How the curve curves, or how the curve bends, like that. Is it better now?
Thank you, teacher.
Okay. Is there any inquiry before we go to part B? Kwagala Faith, is part A okay?
Teacher.
Mm-hmm.
I've not gotten the minimum maximum point. You you said for the minimum it must be
Mm-hmm.
positive after like
The
okay
coefficient of,
your wife.
yeah, it
Pardon?
should, if it is positive, the curve is in this form.
Yes.
So when we are sketching, we take this half. That's what we sketch.
Yes.
Mm. I don't know. Have I answered you? Oh, it is. You can still clarify the question.
No, like I see when I see that you've like circled the 3x squared there and you put positive. Then down you have circled the negative 4x
Yeah,
squared.
because that
You
is
just
what.
look at that.
Yeah, that's what you look at to know whether it should be maximum or minimum. You only look for at the coefficient of x squared.
Oh, okay.
Yeah.
Thank you.
You're welcome. So to know whether it's maximum or minimum, look at the coefficient of x squared. That is for quadratic equations. Remember, we also have cubic equations and quartic, but now we're dealing with quadratic. Quadratic. Okay,
Yes, teacher. Thank you.
you're welcome. Nancy Marlene, is part A okay?
Yes, teacher.
Mm-hmm. Okay. Hannah, is part A okay?
Yes, teacher.
Okay, now we can go to part B. Part B, part B, part B, part B says determine, okay, yeah, find the median and explain what it means. Then also find the decile range, then 70th percentile and semi-decile range. So those are the parameters we're interested in with the median, deciles, quartiles, and percentiles. How do we get them? You should remember, I don't know if I gave you that bullet, but okay, for median, because total probability is always equal to 1, it is half of total probability. So it gives you 0.5, that is median. For lower quartile, total probability, it is a quarter of the total probability. So a quarter times 1, it gives you 0.25. Upper quartile, 3/4 of total probability, which is 0.75. 70th percentile, it is 70 over 100 times total probability, which gives you 0.7, like that. So it all begins from the position. Just as we did in group data of descriptive statistics, we could also first get the position, for example, median position, then can get the median. Lower quartile position, then we get the lower quartile, like that. Even here, we first get the position. The position for median is a half of 1, a half of 1. The reason, 1 in probability is the total probability. In group data, we could get total frequency, okay? But here, we use total probability. And total probability is always equal to 1. So let's say how to get these parameters: median, deciles, percentiles, and quartiles. That is what part B is about. So those parameters involve testing. Testing means where does the median lie? Because we have said median should be 0.5. But where does it lie? Does it lie in this region, or in this region? Like that. These ones can help you. 1 over 6, if you press the calculator, let me first see. 1 over 6, it gives you 0.166. Let's do that. 5 over 6, it gives you 5 over 6, it gives you 0.833. 0.83. Let me first remove this. So this is 0.1667, 0.833, and this is 1. So if I'm looking for median, it means I cannot get it from this function because this one stops at 0.1. Yet for me, I want 0.5. Okay, that means that the only option is median is within this range, because this range of the function, its maximum is 0.833. And for me, I want 0.5, meaning my median is somewhere in this range, somewhere in that range. That is what we mean by testing. First, get the function you are going to use. So in this case, the function I'm going to use is this. Reason, that is where my median lies. Then I can substitute now. Fm is equal to 0.5. So where there is x, you put there m, 1 over 6 in brackets, 2m minus 1 equal to 0.5. So I have got an equation in m, meaning I can calculate for m. So let's do it a little better. So since F3, I mean this one, which we got, F3 is greater than 0.5, it means that median lies within that interval. That's what we mean by testing. F3 is greater than 0.5, so median lies within that interval. And that means that I'm going to use this function now. When I'm going to use that function now, I can say if m is equal to a half. Therefore, when I substitute for m here, I can get the median they want. So solve and be able to come up with the median. And that's what they wanted for median. Okay, so here in capital Fx, we simply substitute. Remember that. Capital Fx, we simply substitute. If you integrate, you are off track. If you integrate, you are off track. That's what should be in your mind. Okay, if there's a question you can ask on median. Yes, is median okay? Elizabeth, is the median we got okay? Is the procedure okay?
Yes,
Yes.
teacher.
Okay. So one thing, so you should always remember that capital Fx we don't integrate. Capital Fx we don't integrate, and we simply substitute. That's the same thing we are going to use for the next part. Next part was about decile range. Now, decile range, it is funny because usually they should give you a range. For example, they can say maybe 4th to 9th decile range. That is okay. But here they have not specified. They have not only said decile range. So each time they don't specify, it means they want the minimum decile and the maximum decile. Let me repeat. Each time they don't specify the range, just even in percentile. Okay, let's first finish decile. Each time they don't specify the range, they want the smallest decile and the maximum decile. The smallest is called first decile. The maximum is called 9th decile, like that. So that means that decile range will be equal to D9 minus D1. You should note it somewhere. When they don't specify that decile, it means you use maximum and minimum deciles. Same applies to percentile. You can also note it somewhere. If the question just says percentile range, it means that you also deal with minimum percentile, which is P1, and the maximum percentile, which is P99, like that. So when they ask for percentile range, it is P99 minus P1. When they ask for decile range, it is D9 minus D1, like that. Okay, now with that knowledge got, we can now answer our question. Remember, this was 0.8, like that. So D9, where does it lie? You realize that here, the maximum is, 9 over 10 times 1, which is 0.9. But 0.9 is no longer in this range. So what does it mean? It goes in this range because this one goes up to 1. So 0.9 lies in this function. Lies in that function. Therefore, when you are writing, we shall now use fx equal to 1 over 6, 8x minus x squared minus 10, like that. Then we let our decile to be something. I can say let D9 be our 9th decile. Meaning that where there is x, I'll substitute for D9 and equate it to 0.9. Then I can be able to get the value of D. So let's see that in the next slide. Hey, okay, there was a meaning for median, which we didn't write. So median, like we always know, median means half of the distribution. So that's mainly what they wanted there. Half of the distribution. So decile range is D9 minus D1. And yet means that it lies in this interval. That's what you have said. If you go back here, it is no longer here now because it stops at 0.833. So it is now in this region from 3 to 4. So you can come and code the correct function. Then remember D9, the condition for D9, for the condition for 9th decile is 0.9. So I can substitute. That is an equation with only one unknown, meaning I can solve it. It's a quadratic. I can rearrange and use the quadratic formula or factorizing, but better we prefer quadratic because some quadratic expressions are not factorizable. Actually, when you see this, it means that it is not factorizable when you see many decimal places. So if the person who chose to use factorizing would get stuck and again come back to the quadratic formula. So to minimize time, it is better you just immediately quote the quadratic formula. Okay, but there should be only one value. There should be only one value. How do you eliminate? You go back to the graph you drew, or you can use this thing here, this interval you say. You said your median must lie between 3 and 4. Okay? But here I have something beyond 4. Meaning that something beyond 4 is discarded. That something beyond 4 is discarded, and we go with this. Then I can conclude that the 9th decile is 3.2254. Okay, if the question you ask about the 9th decile.
I have a question.
Mm-hmm.
How did we know that the 9 decile must lie within 3 and 4?
Hey, it is testing. Let's go back to the graph. Testing. We said in this graph, we said this function has a maximum of 0.16667? Okay. This function has a maximum of 0.833. When you look at this value, it is that. This function has a maximum of 1. Now, because median, our 90 decile is 0.9, it cannot lie here. It cannot lie here. So it must lie here. And this region is from where? Starts from 3 and ends at 4. So that's how we understood it. I don't know, is it better now?
Yes.
Okay. Is a question you ask. Now the same concept is going to be used for first decile. First decile, it is 1 over 10 times 1, which is 0.1. That 0.1 lies in this first function because this first function goes up to 0.166. So 0.1 is within that expression. So that's what I'm going to use. I'll use this 1 over 6x squared to get my D1. Okay, with that understood, we can now go and get the D1. Substitute for x, then get the value of D1. So there are two values of D, but one is outside the range. This range means that a negative value is off. The positive value is what we want. Negative value is off. The positive is what we want. Then after getting the two D1 and D9, I can now get the answer they want by subtracting. And that's what they wanted. You asked if there's an inquiry about deciles. Okay, so I think we can proceed to the next part. So next part was I think 70th percentile. If I see. Next part was 70th percentile, then semi-quartile range. Okay. Now, I want someone to take us through how to get the 70th percentile. Anyone who's ready to take us through how to get the 70th percentile? Anyone? If I want to get 70th percentile, what do I do?
Teacher, let me try.
Okay.
So I think we use the same idea.
Yes.
70th percentile is 70 out of 100 times 1, which is 0.7.
Mm-hmm.
0.7 is going to lie in the region for fx is equals to 1 out of 6 into 2x minus 1. Because 5 out of 6 is 0. Yes, 1
That
out of
is
6.
true. Then from there?
We're going to do 1 out of 6 into 2 times p70 minus 1 is equals to 0.7.
Yeah, I think that is what I wanted. So everything begins from testing to know where it lies. Just as in group data, you first got the position. You could get 70th percentile position. Even here, you have to first test to know where it lies. Then you can proceed. Okay, that's what I wanted. I think we can now come and say that we use that function, then we can substitute the get the P70. Okay, that is it. That is it. If there's a question you ask.
Teacher, I have a general question.
Okay.
So for this class to
For?
draw the graph first before they ask for median, for this kind of question,
Mm.
do they ask us to draw the graph first?
Even if
Draw
you
it,
don't draw
then
the
we can find
graph,
the answer.
okay, is that I'll use the graph for you to see it well. But if they don't ask for you to draw the graph, there is something we wrote. Let me first take you back. Before we sketched, we did these ones. Those are the ones we base on. We know that F1 goes up to maximum of that. So F1 goes up to this. F3 goes up to this. F4 goes up to that. So this is what they want mainly. The graph was to visually show you. But if you can get these, the values of fx for these extremes, that is enough testing. That is enough testing. I think you realize that this is the very one I was writing, 0.833. Even here I was writing 0.1667. Even here I was writing 1. So if you get these ones, you are good to go. You don't need to sketch. You don't need to sketch. Is it better now?
Yes.
Okay. So I want someone else to get for me lower quartile. Anyone to take us through how to get lower quartile? Anyone? We want to. Oh, yes, Vanessa.
Lower quartile. Lower quartile is a quarter, 1 out of 4. So, and a quarter is between 0 and 1 out of 6. So we're going to use the function of equal
First
to
wait.
x squared.
First wait. A quarter is
Oh,
between this. How?
no, it's not. It's not. I'm very sorry.
Mhm.
Yes,
Okay.
when you get a quarter times 1, you end up getting a quarter is 0.25,
Mm,
and 0.25 is between 1 out of 6 and 5 out of 6.
that is true.
So you use
Therefore,
the function. So you use the function of fx is equal to 1 out of 6
mm,
x minus 1.
how are you going to use it? Mm-hmm. How are you going to use it? Vanessa, you see?
That's all I had.
Eh, okay. After knowing the function, you have to
That's all
let.
I had.
Yeah. After knowing the function, you have to let. You can say let Q1 be the lower quartile. Like that. So that you can use it, you can say if Q1 is equal to 0.25. Then use this function here and say 1 over 6 in brackets 2 Q1 minus 1 is equal to 0.25. Then from there, you can easily get the value of Q1. And also do the same for upper quartile. So basically, that is how they get deciles, medians, quartiles, and percentiles. Basically, that is how they get medians, quartiles, deciles, and percentiles. First get the position, then identify the function to use, and you're good to go. So if there's a question, you can ask, but basically that's how they get it. They get them. Deciles, medians, quartiles, and percentiles. If there's a question you ask on those four parameters. Okay, so I think they are now okay. So we have seen how to get how to sketch capital Fx, how to get the constant, how to get decile, quartile, percentile, and median. Okay, now let's see the next part. Like I've told you, the question is more wordy. I only wanted to capture all the parameters. So an item cannot be this wordy. An item cannot be this wordy. I only made it wordy so that I can capture all the parameters. Okay, then part 2 says determine the probability density function. Okay, and hence capture the average delivery time and variability of the delivery times within Kampala. So we remember that PDF we get by differentiating. Then this average time is expectation. This one is EX. Then variability is var x. And like I think you already know, even if they don't tell you to get the probability density function and they ask for mean or variance, automatically you must first get small fx. Automatically you must first get small fx. Like that. So let's first get small fx and we see how to get the expectation. So we get it by differentiating. So when I differentiate, that is what I will come up with. And that will be our fx. Then to get expectation, you think, remember it is x fx. So you multiply x on each. Multiply x here to get this, multiply x here to get this, multiply x here to get this. Then I can integrate. Okay. Anyone to give us what we write after integrating? I want to integrate a third x squared. What do I get? Yes, anyone there?
Yes. Get 1 out of 9 x power 3.
Okay. Then the next, a third x, what do I get?
1 out of 6
Mm.
x squared.
Okay. Then the next, what do I get? Are you still there?
Yes. We get 4x squared
Or x
out of
squared out of 6.
minus x cubed out of 9.
Yeah, that is correct. That is correct. So you integrate correctly, then you can substitute. So integrate correctly, then substitute the limits, then you'll be able to get the value of EX like that. So basically that's what they wanted for expectation. If you have a question, you ask. For me, in the integral, what I did, I first pulled these ones out. Pull this out, then I only integrate this to give me a third x cubed. Pull this one out, then I integrate this alone to give me a half x squared. Pull this out, then I integrate this alone to give me that. So basically that's how I integrated. I first pull the constant out. Okay, here's the question you ask. Here's the question you ask. Before I go to variance.
Teacher,
Mhm.
this isn't a question, but there's a suggestion.
Okay.
For the previous part of percentile and lower quartile,
Mhm.
like I was requesting if I could copy down the notes if possible.
If you could.
Copy down, like you were scrolling too fast. I wasn't able to finish up copying.
Hey. Okay, but you can still take a screenshot. Let me first see.
All right, no problem.
Let me first see. We're on. You said this
For
one, right? This one, right?
yes.
Okay.
Also the
Then
one for percentile and lower quartile.
it is okay. Just do this. I think I put it on group.
Yes.
Then you said lower quartile. This one.
Yes. Yes. Yes.
Screen. Okay, I think that is it.
Yes. Thank you.
You're welcome. So we shall end on variance for today. The rest will be done tomorrow. So for variance, it is x squared fx. So on fx, we multiply by x squared to get these. Then you still integrate. Then substitute the limits. So I think you were aware that your calculator can easily give you an answer when you feed in this expression. So before you go to the next question, I encourage you to double check. After doing all these integrals, double check, see if this one can give you this. See if this one can give you this. And see if this one can give you this. Because some students can integrate well, but here along using the calculator to manipulate these substitutions, they get a wrong value. So I encourage you that for accuracy, you double check with the calculator. Put this in the calculator and see if it gives you this. Put this and see if it gives you this. And put this and see if it gives you this. They'll be sure that what you have written is a correct integral. You'll be sure that you have written is a correct integral. Okay, so basically that is it. And it's an inquiry, but we are good to stop. Okay, I think let's also take the screenshot of this. Okay, so tomorrow we shall still continue with continuous random variable. But I still remind you, some of you have not yet sent me the papers of your school. I encourage you to send that we can see how to add it in these items. Otherwise, have a good day.